This lesson goes with section 9.6 in your textbook and answers the question, what do you do if there's a coefficient on the x squared term? In other words, how do we factor an expression that has the general form ax squared plus bx plus c, where a, b, and c are non-zero numbers? First of all, let's back up a little bit and see how FOIL, that is a way that we multiply together two binomials, can result in an expression that looks like ax squared plus bx plus c. Here I've shown two binomials, x minus 3 and 2x minus 1. If we multiply them together using FOIL, or if we multiply them together using a table, here's what it would look like. X times 2x would give us 2x squared. In this case, 2, the coefficient in front of the x squared term, is the a in the general pattern above. X times negative 1 would give us minus 1x. Negative 3 times 2x would give us minus 6x. And negative 3 times negative 1 would give us positive 3. When we combine the like terms in the middle, the negative 1x and the negative 6x, we would get negative 7x. So we would have the expression 2x squared minus 7x plus 3. This is an expression of the form ax squared plus bx plus c. Our goal in this section is to figure out how to work backwards. If we start with 2x squared minus 7x plus 3, how do we get back to the factors of x minus 3 and 2x minus 1? So here's an expression that we're going to use as an example problem. 3x squared plus 14x minus 5. How do we factor this? Well, the first thing we need to do is look at all three of the terms and ask, is there any common single factor that we can factor out of all three of them? In the example shown above, there isn't. There is no common factor to all three of those terms, so there's nothing we can factor out of all three. The second thing we need to do is to think what we're really trying to do is to unfoil. We're trying to go backwards to two polynomials that we could FOIL together. I find it's helpful if we start out by figuring out what the signs in these two polynomials are going to be. So I notice that the last term in the expression is negative 5. So I multiply two numbers together and my answer is negative. This suggests that one of the last terms needs to be negative and one of them needs to be positive. So I'm just going to write those signs in. Next, we're going to use some guess and check. So I'm going to set up my area model here. I know that when I multiply the first two terms of the factors together, I need to get 3x squared, so I put that in the first box. When I multiply the last two together, I need to get negative 5, so I put that in the bottom right-hand box. And the two middle terms, the o and the I in FOIL, need to add up to 14x. So what I need to do is try some combinations of factors and see whether the oi in FOIL works out right. Let me look at the 3x squared term first. One way I can get that is by multiplying 3x times 1x. So I put those two factors in place. Next, I'm going to look at the negative 5 in the bottom right-hand box. How do I get negative 5? Well, one way I can do it is I can multiply negative 5 times positive 1. There are the two signs that we found on the previous slide. So this is a guess at a way that we might factor this expression. The question is, do the two empty boxes here, when I fill them in my area model, do they add up to 14x? Let's give it a try. So the possible factorization that we're considering is 3x plus 1 down the left side and x minus 5 across the top. What would the OE be in this case? Well, negative 5 times 3x gives us negative 15x, and 1x times 1 gives us 1x. So the OI in this case would be negative 15 plus positive 1x, sorry, that's negative 15x plus positive 1x, that would add up to negative 14x. That's not what I'm aiming for in the OI. I'm aiming for positive 14. So the good news is my guess gave me the correct number for the OI. The bad news is I got the wrong sign. I got a negative OI when I was looking for a positive one. One thing that I'm going to try and do then is I'm just going to switch the positive and negative signs on the plus 1 and minus 5 in my factorization. So I'm going to take that negative 5 guess away, and I'm going to replace it with positive 5. And then I'm going to take the positive 1 factor guess away and replace it with negative 1. Notice that this still gives me, when I multiply negative 1 times positive 5, this still gives me negative 5 in the lower right-hand corner. But now I need to change the OI that I have. In the top right-hand corner, now I have positive 5 times 3x. That's positive 15x. And in the bottom left corner, I have 1x times negative 1. That gives me negative 1x. And notice that now I have a new possible factorization. I have 3x minus 1 times x plus 5. Let me check the OI now. I add negative 1x and positive 15x together, and I get 14x. That is the correct middle term, the correct outer and inner products using FOIL. So this is the correct factorization. Notice if I take those two factors, x plus 5 and 3x minus 1, and I multiply them together using FOIL, the first term, 1 times 3x, gives me 3x squared. The outer terms, 1x times negative 1, gives me negative 1x. The inner terms, 5 times 3x, gives me 15x. And the last terms, 5 times negative 1, gives me negative 5. Now, I'd like you to practice. Here's a polynomial, 4x squared minus 9x plus 5. I've set up the area model here. 4x squared needs to be the first term. Positive 5 needs to be the last term. And the middle two terms need to add up to negative 9x. What I'd like for you to do is to try some possible factorizations until you can get a combination that makes the OI work correctly. Please pause this presentation while you work through that. So if you had factored this correctly, what you should have found is that your first factor is the quantity 4x minus 5, and your second factor is the quantity x minus 1. If you got something different than this, I would suggest that you go back and check your work to make sure that when you use FOIL to multiply together what you found as the factors, you get the correct answer. If you're feeling like the process of guessing and checking different factors and combinations that will make the middle term, the OI and FOIL, come out right, here's a more step-by-step approach that you can take. This is a little bit complicated, but the steps are reliable and will always result in you getting the right factor combination. This method is called break and group. What we're going to do is take our trinomial that has three terms, 3x squared plus 14x minus 5. We're going to break the middle term up into two terms, and then we're going to use factoring by grouping our four terms in order to find the correct factorization. Let me show you with an example what this looks like. The first thing that I'm going to do is I'm going to look at the first coefficient, that's the coefficient on 3x squared, and the last term, the negative 5. And I'm going to multiply those two numbers together. 3 times negative 5 equals negative 15. Now I'm going to focus on that negative 15 number, and I'm going to ask myself, what are the factors of negative 15? And I can list out some of those factor pairs. Negative 3 times 5, negative 1 times 15, 3 times negative 5, 1 times negative 15. I'm going to look down this list of factor pairs and ask myself, which pair adds up to the middle term? Which pair adds up to 14? And I notice that one of those factor pairs is negative 1 and 15. Negative 1 and 15 add up to 14. So I'm going to use this middle pair, or this pair of factors, to break my middle term. So 14x, I'm going to rewrite it as negative 1x and positive 15x. The negative 1 and the plus 15 are the factors of negative 15 that add up to 14. You see now that I've rewritten my original trinomial that had 3 terms as a polynomial with 4 terms. The two expressions are equivalent because the middle terms in the second expression add back up to 14x. That's the break part of breaking group. Next, I'm going to do the group part of breaking group. I'm going to look first at the first 2 terms, 3x squared minus 1x. And I'm going to ask, is there anything I can factor out of both of those terms? Well, it looks like I can factor an x out of both of those. When I do that, I end up with x times 3x minus 1. Now, I'm going to look at the second group, the 15x minus 5, and I'm going to ask, is there anything I can factor out of both of those terms? Well, it looks like they both have a 5 in them. So I'm going to factor out a 5, and what's left behind inside the parentheses then is the quantity 3x minus 1. Now that I've done this factoring of each individual groups, I can look at this whole expression and say, is there anything that I can factor out of both the first and second chunks of this expression? Do they have anything in common? Well, they both have the quantity 3x minus 1 as a factor. So I can factor 3x minus 1 out of both terms. And when I do that, what's left behind is x plus 5. So now I have the correct factorization of 3x squared plus 14x minus 5. It is x plus 5 is the first term, and 3x minus 1 is the second factor. What I'm going to do next is walk you through a set of instructions, a step-by-step what to do, because this process may look a little bit mysterious at first. For the next set of notes, I'd suggest that you make a 2-column chart. In one, you have directions about how to do each step, and in the other, you have an example of what that looks like. So what we're going to try and do is factor 2x squared plus 13x minus 7. Step 1 is to multiply together a and c. That's the coefficient on the x squared term and the constant at the end. And please be careful when we do this of our signs. So in this case, a times c is 2 times negative 7, which is negative 14. Step 2. Look at the answer to step 1 and ask, what are the factors of that number that add up to b? So in this case, we're asking, what are the factors of negative 14 that add up to positive 13? In this case, those factors are positive 14 and negative 1. When we multiply them together, we get negative 14. When we add them together, we get positive 13. Step 3, separate the middle term, in this example plus 13x, into 2 terms that add up to that middle term using the factors that you found in step 2. So we're going to add 14 as a coefficient on one of those terms and negative 1 as a coefficient on the other one. Step 4, group the 4 terms that you found in the previous step into sets of 2. So I'm just inserting some parentheses here to make 2 groups of terms, a first group and a second group. Step 5, look at each of these groups you created with your parentheses and see what monomials, what single factors you can factor out of each one. So in the first case, I can factor out a 2 because 2 is a factor of both 2 and 14. And I can factor out an x because x is a factor of x squared and x. When I do that, I get 2x outside the parentheses because that's what I factored out. What that leaves behind inside the parentheses is 1x plus 7. Now I look at the second group, and I can factor a -1 out of both of those terms. What that leaves behind inside the parentheses is positive x and positive 7. Step 6 is to take these things inside the parentheses, which are both x plus 7, and factor that whole quantity out. So I take the x plus 7 and factor it out, and what's left behind is the 2x plus -1. We could also write that as 2x minus 1. Now I have the correct factorization of my original expression. If when you do this, you notice that the stuff inside the two parentheses doesn't match, ask yourself whether factoring out a -1 would make the stuff inside those parentheses match.